Hello guys, how's it going? Hello, hello. Hello, hello. Okay, I'm just gonna change the audio to hello. Okay, that's good. Now we can start. Okay guys, this is our last chapter in our course of engineering principles in Python. And this is gonna be the last chapter of this 8th course, which is the pre-last course of the AI engineering for developers. So sorry, yeah, AI associate path for developers. So let's just finish this today. Then let's go to gym, make some projects, and then tomorrow probably or today afternoon we're gonna keep doing the last chapter, which is doing these pipelines with Langchain. So let's just jump into it.
One of the big software engineering concepts that all Python users benefit from is documentation. Documentation in Python can take the form of comments. Comments in Python are led by the pound symbol, as you see here. They can sprinkle in information about your code for future collaborators. Another way of documenting code is to use docstrings. Docstrings are invoked by the use of triple quotation marks like you see here. They are typically used to document functions, classes, and scripts for your users. Let's look at both of these in a little more detail. Comments are used inline to document what a particular line of code is doing and why. They can appear on their own line or at the end of a line of code. A big difference between docstrings and comments is that comments will not be seen by your users unless they are looking into your source code. The goal of good comments is to make your code more readable for both yourself and collaborators. There is some debate on the usefulness of comments. Take a moment to look at these comments. As you can see, they don't add much value. Unless the code is trying to teach someone about Python basics, then these could be useful comments. So it's important to know your audience when commenting. However, a good rule is that comments should explain why a line of code is doing something and not what the line of code is doing. Here is the same code with different comments to explain the why of the code. In my opinion, over-commented code isn't nearly as big of a headache as under-commented code. If you ever have a question of whether or not a comment is useful, I would suggest adding the comment. Comments are documentation for yourself and collaborators. Docstrings are documentation for your users. Docstrings are what Python outputs whenever a user calls help on your functions and classes. Let's look at the anatomy of a docstring. The first section describes the functionality of what we're documenting. Next, we document the parameters and return value of our function. We use this particular syntax with the colons by convention so that downstream tools can take our docstrings and convert them into website-based documentation. You can see an example of a web page generated from a docstring formatted like ours at this link, which shows the documentation for the popular Flask package. Last, we can document example usage and expected output. The 3 chevrons show the example function call, and the next line will represent the expected output. Here we see a docstring actually filled out to describe a function and its usage. It contains a brief description, information on the parameter and return values, and an example showing how the function is used. In the case of this simple function, the optional details section wouldn't add much value, so it's been omitted. In addition to the docstring, we see comments explaining why the code was written a certain way, as opposed to what the code is doing. Now that we've written the docstring for the square function, users can access it by calling help. When they do, they'll see this printout showing all the information they'd need to understand what it does and use it properly. Note, as mentioned before, the users don't see our comments that describe our implementation details to future collaborators. We just covered how to write effective comments in docstrings. Let's jump into some practice.
Okay. So in this part we're doing we learn about characteristics to make a good comment. You will apply this notice and identify the function that comment. Let's comment best practices. Okay. Print the text. variable that has been preloaded in your environment. And then print the result of calling the function. Better commenting. Okay, it's this one, because this one touches specifically what it does is talk to the amounts from the text. Yeah, so we're gonna do 11 root commenting. Identify proper doc strings. Fully fledged doc strings before writing one of your own. This example will help you have identified a properly formatted doc string. This is you will be using the functions Goldilocks, Rapunzel, Mary, and Sleeping Beauty. Print help on each of these 4 functions. Okay, help, Rapunzel, Mary, and Sleeping Beauty. Okay, good. And now it says define the result using the function. Has the most complete doc strings. Only one offer contains all the sections we covered. Okay, first Goldilocks. It doesn't have description, so it's bad. Rapunzel has descriptions, has a return statement. And this is good. And Sleeping Beauty. I think it's just this. Then her cannot be negative. This is the one that should tell exactly what it does. "13 days strike." If we finish this like whole path in 14 days, it's gonna be a hit, man. I think it was super fast. Writing doc strings, which learned some about the benefits of doc strings. In this exercise, you will practice writing doc strings that can be utilized by a documentation generator like Sphinx. The doc string submission must match the solution exactly. If you find yourself getting it wrong several times, it might be a good idea to refresh the same code and start over. So, portions of the string that documents these parameters. So here is the return that explains what it returns. So here is a param. Text is the text to be tokenized, and then the para regs, which is the regular expression. And for example, here's an example. If I do tokenize the rain in Spain, I will do 4 of them. Okay, and then I'll do this because this is a split by word, I think. Well, let me check it later, but let's just make like this. Yep. Okay.
Another important step to writing a maintainable project is readable code. Luckily, Python has a big focus on readability, and it comes with a list of guidelines to help write good code. These guidelines are known as the Zen of Python, and you can view them through the command import this. Here we see an abridged version. Notice the item stating readability counts, and the rest of the items can guide us in this quest for readability. One way to aid in readability is with good naming. Look at these two functions. Both implement the same logic. However, if we believe readability counts, then the isBoiling function is a better option. The isBoiling function describes what it's doing thanks to descriptive naming. This is known as self-documenting code. However, remember that undercommented is a bigger issue than overcommented code. If you're ever in doubt, add comments. A warning about descriptive names. It's possible to go too far. Modern IDEs have autocomplete, so it might not seem like a burden to type long names, but long names can make code hard to read, as you see here. Note, even if your code is self-documenting, your users will appreciate the ability to call help and see all the good information a docstring can provide. Another way to keep your project readable is by writing in simple, maintainable units of code. Let's take a look at an example by writing a function to make a pizza. Take a look at this code to make a pizza. Notice that the full definition doesn't fit on the slide. Although we're working with a small screen, not being able to fit your function on the screen is a sign that it maybe should be refactored. A less obvious issue is that we have a few different processes happening that could stand on their own. We're making dough and then making a sauce. We might want to be able to make dough outside of the pizza process. Let's do some refactoring. Take a second to look at this refactored function. It's easier to see what's happening in both a functional sense and a literal one since we were able to fully fit it on the screen. By breaking processes out into their own descriptively named functions, we can see the high-level process of making a pizza at a glance. An additional benefit of defining these smaller functions is that we now have more modular code that we can easily plug into different recipes that might call for our homemade marinara. These also make writing tests easier, which we'll soon be covering. Our rewrites came about thanks to a couple warning signs. They were that our function was a bit long and we had separate processes happening. You should strive for functions to accomplish one and only one thing. In our pizza example, we were using comments as section headers to denote different processes. If you're ever doing that, then it's a good bet that your code should be split into smaller functions. Another warning sign that your function is doing too much is if it's hard to think of a good, meaningful name for it. Unfortunately, you might not notice your code is hard to read until trying to read it the next day. Just strive to do your best, and to repeat once more, document your code with comments and docstrings. We just covered some important topics about readable code. Let's practice.
Okay, using good function names. Just the name of it. The model has allowed and given the facility to staff hypotenuse length. So this is the squared of a plus the square of to the power to 2, and then my square root is going to calculate the hypotenuse length. So a good name for this is do like this. Print the hypotenuse length of 6,8. And yeah, using good variable names. Just like function description variables can make your code much readable and extends you write some code using good variable naming practices. There's not always a clear best name for a variable. The exercise can be written to try and make clear best choice from the provided options. So I guess this should be pupil diameter, the mean pupil diameter. So this is the mean diameter, and then diameter, and we can refactor into readability. Call both readability shown below. Move the logic of calculating perimeter into polygon perimeter. So V should be end size times side length. Polygon apothegm. Removing the logic. Side length and denominator. And the denominator is this. Fuck, mosquito. Okay, then the polygon area should be the perimeter. This, then the apothegm with this, and then we return the perimeter, the apothegm. Nice refactor. I just run it now. Good. Not the unit testing. I think this is a part that a lot of developers
Even
hate.
well-documented, readable code isn't very useful if it doesn't work correctly. That's where testing can come in handy. With testing, you can confirm your code is working as intended. You probably already run some manual tests. Instead of writing these tests in the console, you could add much more value to your project by adding these to your test suite. A written test can be rerun after you make changes to check if there were any unexpected effects. Also, changes in dependencies can sometimes break your code. Automated tests can alert you to problems like this and more. So how do we test in Python? We'll cover two easy-to-use options, doctest and pytest. Thanks to writing informative doc strings with examples included, you've already written tests that can be run with doctest. Let's look at an example with this square function. To use doctest, we need to import it and run the test mod command to test our modules examples. When we run the test, we see that failed.
What?
So how do we test in Python? We'll cover two easy-to-use options, doctest and pytest. Thanks to writing informative doc strings with examples included, you've already written tests that can be run with doctest. Let's look at an example with this square function. To use doctest, we need to import it and run the test mod command to test our modules examples. When we run the test, we see that it failed. Looks like there is a typo in the doc string.
So here we're defining already the example square of 3, it's 9. But I got 27. So here in the examples, it's like...
That was caught thanks to doctest. If there were no failed tests, the output from test mod would be blank. Doc tests are great for smaller examples, but you often can't cover every case you want to test in a doc string. For example, if your function returns a large pandas data frame, this could be hard to include as a doc test. For larger cases, there's PyTest. To use PyTest, I recommend a test directory at the same level as your packages directory. Due to PyTest flexibility, there are other options. For example, if developing a larger package, it might be useful to break out sub-package tests into their own folders. Let's write some tests for our document class. First, notice the test underscore prefix. PyTest searches for tests by first looking for files that start or end with the word test, and then PyTest runs all the functions in these files whose names follow the same pattern. Within our test method, we've then created an instance of document as our test case. Last, we run the actual test with the assert keyword. As long as the assertion is true, our test passes. When testing, it's also a good idea to test for the edge cases that you can think of. For example, here we could test the expected attributes of a blank document. Note that when testing class attributes,
This is this sound is super scary. It sounds like the war is gonna start, but I hope it's not, because this is the sound. I don't know. Okay, doc tokens. So this is the function definitions, sentence similar than in JavaScript. In the assert, you make the assert
of a blank document. Here, we could test the expected attributes of a blank document. Note that when testing class objects, it's not wise to compare two objects with double equals. Here, we create two identical document objects and test equality. Our test shows the objects are not the same.
Of course.
Instead, to compare objects, we can compare attributes as we see here. To run our tests, we head to the terminal in our workdir directory, run the command pytest, and wait for our output. We see that all of our tests passed and our code is running as expected. If we just wanted to run the tests in one file, our command might look something like this, and we'd only get the results for that file's tests. So far, all of our tests have passed. Let's look at some output of when things go wrong. In the output, we see exactly which test failed and even how it failed. This information can be a lifesaver when your projects grow and tracking down bugs becomes a more time-consuming process. Okay, we just covered the how-tos and benefits of doc test and
okay. Using doc test. He's learned about doc tests, which are writing full doc strings to examples as a way to minimally test your function. It's such you will get some hands-on practice testing about debugging with docset. Okay, in the text analyzer object that we have, we get a document, and then here another document, then we are doing the sum of the counters, which is gonna be here sum counters, and then in here is gonna return the reply, which is going to be a counter. So if I do this doc test dot test mode, and you get this expected, it got a counter. I received like a counter like this. So I need to choose this 1 second, because this is the right counter. Okay, I think it will, if you will fail, I will get something like this, expected like received. The doc test is a great tool, but it's not nearly as powerful as PyTest. You'll write a test with social media using the class PyTest. Oh wait, actually this is gonna be really useful. Now in these sum counters, we had it somewhere here. Here, it's here. And here we can actually put the description here. And it's all at the same level. Okay, so I need to yeah, and yeah. Okay, so it's all at the same level. And then in here, if I do run the doc test mode, and then I do this, and then I do this, and then probably if I run this is in counter utils. So I should go to here to cd. So it's not there. Ah, it's the text analyzer. Item counter utils. Here it should appear the text. Just meanwhile I'm gonna run cloud in this side. Okay, I'm getting, so I need to import the test, I assume. Then I need to run this. I'm running cloud here just in case. And then here's not defined, so I need to do some counters. And then I should return here the counter object with the some counters. And here's the counter object. Like this, run the code. Ah. And I should do here the test mode from here. Then we'll run it. And then, okay, this is the one that we want to replicate. And now it should run okay. Okay. I'm getting this error on this code. Let's explain why. uh, uh-huh. So in my case, I think it's better should do import document from document. And then I just need to do this, because the document should have already the word counts there, yeah, which is already the count words, which returns a counter. Okay, so let's run it again. Let's do this in the other way around. Attended the relative import with no parent package. Like this. Okay, I don't know what's going on. No, the error. Mm. So I should do in this case this. Oh no, so I guess okay, I'm gonna ask to better fix this. Because maybe it's because we're running this in inside of a module. I'm gonna go to the next. Here we need to. Okay, before you start rent, you need to be working in a proper name file for PyTest. To find your test, which one we're going to find contest for social media? Social media tests, I guess it will be. So I should start with test. Alright, and the 2 is like import the social media class. Then create this is the post and the social media, and then this should be return SM hashtag count, expected hashtag count. Keyword that is the hashtag count. Should be here test social media has. Get a help. The assert. Okay. No, to correct vision, the top from document. So I need to run it as a model. Okay, so then yes, please. Okay, give me 1 second. So I need to import this, and then when I want to run it, yeah, just this. And then when I want to run it, I should go to the parent folder and do the Python and run a model, text analyzer, counter utils here. You need to run it like this because it's a model. Item has 3 failures. Let me check. All right. So then if I just say this. Okay, I think so far it's good. Let's run the next lecture.
Our last step is to look at documentation and testing in the wild. We'll cover some useful tools and their benefits. We won't go into detail on how to implement everything, but there's a lot of good documentation online for the tools that we'll cover. Also, these tools won't be available in the course exercises for practice. Sphinx was mentioned earlier as a tool that transforms doc strings into beautiful documentation. Here we see an example of what your document class might look like as an HTML page generated by Sphinx. All of this benefit just from writing complete doc strings. If you're managing your project with GitHub or GitLab, then you can even host your Sphinx-built documentation for free using the product services. That way, users can search the web to find your helpful documentation. You might have noticed that the example Sphinx page showed documentation for a class and included information on attributes. Let's take a quick aside to look at the doc string that was used to build the page. This doc string should look mostly familiar, but here are a couple things to note. We document the parameters for the init method in the class docstring. This way, users can see how to initialize a new instance by calling help on the class itself. Next, we document attributes using the ivar keyword. This abbreviation stands for instance variable. With this documentation in place, users can easily see how to use your class. By using PyTest extensively, you'll be able to have most, if not all, of your project's code being tested. But it can be a bit of a bother to have to always run the tests repeatedly from the command line. This is where tools like Travis CI come in. The CI stands for continuous integration, and it just means that you are continually adding new code to your project. When adding this new code, Travis can automatically run your test for you and alert you if your changes broke something. Then, when you push a fix, Travis CI will run your tests again to double check that your fix was successful. Another great aspect of Travis CI and other CI testing tools is scheduled builds. By scheduling a build, your tests can be run periodically even without you adding new code. Scheduled tests are a great way to catch bugs introduced by updates in one of your dependencies. To close out, let's list out some links for the tools we've covered and some additional ones. First, here are links to the tools we just covered. Next, GitHub and GitLab are great for storing open source projects. They are based on the tool Git. To learn more about Git, you can check out the related DataCamp course. CodeCov is a tool that lets you explore which parts of your code are being tested by your automatic tests. This is known as test coverage. By keeping your project's test coverage high, you will be less prone to surprise bugs. CodeClimate is a tool that will analyze your code's readability. It can point out when a function is getting too long, or even if your code is a little confusing in spots. Fixing the issues it points out will help keep your project more maintainable. Both CodeCov and CodeClimate can be integrated with Travis CI to run automatically on a schedule and with each addition of new code. We just learned about some amazingly helpful tools for software engineering with Python. Let's practice.
Okay, now document classes for Sphinx. So Sphinx is rated for rendering documentation. Import the document from text analyzer. Import document. Then in here let's check. This is the forum. Social media text analyze. And then here we do the iBar, I think. Let me check. iBar hashtag counts, and the same with the mention counts. Then we do run the code. Submit this. Get some help. Because in the it extends the document, but actually in the init should be the text. All right. I know here param and text like this. Give you what you learn to go faster today. Nah. Okay, identifying tools. Which one of the following list of tools best corresponds to the trace over engineering concepts? Modularity, documentation, automation. The correct answer will have tools listed in the order that best correspond to which concept they help you with. Okay, so I should do modularity, documentation, and automated testing. No Travis CI, Python, no. Modularity documentation and automated testing. Modularity documentation and automated testing. I think it's this. Modularity is code climate to see if it's like well packed. Sphinx is for documentation and Travis for automated testing. Good. All right. Congratulations on finishing the course.
Congratulations on completing the course. You've come a long way. Throughout the course, we explored the ideas related to the major concepts of modularity, documentation, and automated testing. With modularity, we learned about things such as functions, classes, packages, and the dry principle. We learned how docstrings, comments, and Sphinx can help document a project, and we learned how PyTest, DocTest, and Travis CI can be used to help implement automated testing. Hopefully, you'll agree with me that applying these concepts in your data science workflow will lead to much more maintainable code. Following these ideas will even help you in publishing your own open source tools for data science that your users will love. Thanks for coming along with me as we learned about software engineering for data science in Python. I hope you learned a lot. Good luck in your future software engineering projects.
That's awesome, guys.
Congratulations on completing the course. You've come a long way. Throughout the course,
we finished this. We got it. Now we only have one last course in the work in the associate AI engineer for developers. So let's go into the learn part. And let's go into here. We see we almost finished. Now we need to do LLM applications with Langchain. And after this, we're gonna go right away into the projects. 3 open projects, 3 open source contributions, and 3 implementations in plateaus. So